Another example. The rainfall in the Red River Valley was 33 inches this year. The average rainfall is 30 inches. This year's rainfall is what percent of the average rainfall? So our unknown is the percent that this year's rain was compared to the average rain. What we do know is that it's 33 inches this year, 30 inches on average. So we're going to assign our variable. Our variable is the percent, so P will be the unknown percent. Our equation, again, we're going to use a hybrid situation where we're going to write it kind of in words first. This year's rainfall is what percent of the average rainfall? So this year's rainfall we know is 33 inches. Is your equal sign. What percent is unknown? Of is multiplication, and the average rainfall is 30. This is our equation. We're going to solve this by dividing both sides by 30, and we get 1.1 equals P. Remember, when you're using the equation, your answer will always come out as a decimal, and you need to convert it to the percent. So this would actually be 110%. That is the only real difference between percent equations versus percent proportions. If you're using proportions, the answer is exactly what it needs to be. There's no moving decimals. So make sure you keep those two things straight. So this year's rainfall is 110% of the average rainfall. Does this make sense? Yes, because this year we got 33 inches, which is more than the average. If we got exactly average, we would be at 100%. But since we're more than that, we're going to be a little more than 100%. Hence, 110% is a reasonable answer. Another example. A newspaper article stated that 648 pints of blood were donated at the blood bank last month, which was only 72% of the number of pints needed. How many pints of blood were needed? So our unknown is the number of pints that were actually needed. What we know is that 648 pints were donated, and that this 648 is 72% of whatever was needed. Our variable will be our unknown, the number of pints needed. In this case, when you write an equation, again we'll use the hybrid situation, rewrite a sentence for ourselves. 72% of the number of pints needed is 648 pints. When you're using the equation, convert the percent into a decimal. Of is multiplication. The number of pints needed was our unknown variable. Is our equal sign, and then our total was 648. So in this case, our total is unknown. The subset or part of it is given to us. Solve this by dividing both sides by 0.72, and we get n equals 900. So 900 pints of blood were needed. If we check this, it makes sense. 10% of the 900 would be 90 pints. So 70% would be 7 times 90, which is 630 pints, which is close to the number given, which was 648. So our answer is 900 pints of blood were needed. Our next topic is solving problems involving percent increase or percent decrease. These are kind of things you'll see a lot when you're reading articles in a newspaper or listening to the news. They talk a lot about the wages of the percent increase in the wages of CEOs, or the percent decrease in the number of people paying back, getting mortgages, etc. When you're finding percent increase or percent decrease, the first thing you have to do is subtract to find the actual increase. Most of these problems will give you the original amount and a new amount, and you need to subtract them to figure out how much it changed. So the big thing is figuring out what the actual change was, what the actual amount of increase is or amount of decrease. Once you get that, then you can put it into either the equation or the proportion. So in the equation, it's the percent of the original value equals the amount of increase. In the proportion, you're going to have percent increase over 100 equals the actual increase over the original value. The really other big key thing is that you're comparing it to the original value. The problem will always give you two numbers, a starting value or original value and a new value. The biggest mistake is that students compare the change to the new value, which will give you the wrong percent. So make sure you're comparing it to the original or starting value. Example, Brad's hourly wage as an assistant manager of a fast food restaurant was raised from $9.40 to $9.87. What was the percent of increase? So what we don't know is the percent increase. What we do know is that the original hourly wage was $9.40 and the new hourly wage is $9.87. Our unknown is the percent of increase, so we'll let that be our P. To actually put the equation together, the first thing you have to do is figure out the actual increase. So you're going to subtract your two values. So he actually went up by 47 cents. That was his actual raise. Now what we want to figure out is 47 cents is what percent of the original wage. So our percent is unknown. Of is our multiplication. The original wage was $9.40. The amount of increase is this 47 cents. Solve this equation. Again, this would be some nasty arithmetic, so I would grab a calculator for this. Oh, never mind. It's easy arithmetic. I was thinking of the next problem. So our percent is 0.05. Again, when you're using the equation, your percents will come out as decimals, so you have to convert them to the percent. So he got a 5% raise. You can check this. 10% of 940 would be 94 cents. And a 5% raise is half of that, which is 47 cents, which is about what he got. So that works out. Percent decrease are the exact same things. Instead of finding the amount they increase, you're just going to subtract to find the amount they decrease, but the general setup is the same. Again, you can use an equation or a proportion. Rosinia trained for 6 months to run in a marathon. Her weight dropped from 137 pounds to 122 pounds. Find the percent of decrease. Round to the nearest whole percent. Pay attention when the problem tells you to round. That's when you have the nasty arithmetic. We read the problem. The unknown is the percent of decrease. Known was that she originally weighed 137 pounds, but her new weight is 122 pounds. We'll let P be our percent of decrease because that is our unknown, so that's our variable. This time we're going to set up using a proportion. We still need to do the subtraction to find the actual amount of increase or decrease. That's the same whether you use proportions or equations. So 137 minus 122 is 15 pounds. So the actual amount of weight she lost was 15 pounds. So our question is 15 pounds is what percent of her original starting weight. So we're comparing the decrease, the loss, to her original. So P is our unknown percent of decrease over 100. The actual decrease was 15 pounds and her original weight was 137 pounds. Solve this, multiply both sides by our denominators. We get 137p equals 1500. Divide both sides. And you see we get some really nasty decimals here. This is why they told us to round. It rounds to 11%. So she lost 11% of her body weight, or her weight decreased by 11%. We can check this. A 10% decrease would have been 13.7. An 11% decrease is darn close to that, which is what we had. So that is a reasonable answer. That concludes section 7.4. Your next steps are to complete the worksheet for section 7.4, then check the key for that worksheet, then complete the online homework for section 7.4 through My Math Lab, and lastly start on our very last section, section 7.5.